Okay, welcome to your Chapter 4 study guide and review online. Any problems or questions that you have, we can talk about in class either tomorrow or tomorrow afternoon before the test. So definitely take your time. There are 2 review guides posted, one with answers, one without answers. So take your time and decide whether or not you need any extra help with any of this. Okay, so let's get started. First, vocabulary. So basically, these are all the different vocabulary terms that we have discussed through Chapter 4. Take a look at them. Hopefully, you remember what they all mean and know how to use them in the different graphing functions. Okay? I'm not going to go through these one by one. If you need a definition, they are on these pages in the textbook that is on my website, which probably no one has ever looked at before. All right. Okay, so this from here on, I'll go through pretty much everything on here. Okay. So first, state whether each sentence is true or false, and if it is false, replace it with the underlined term to make a true sentence. So the sine of an acute angle in a right triangle is the ratio of the lengths of its opposite leg to the hypotenuse. Okay, that is true. Remember that we are going to use the Indian chief's name, Toa. Okay, we're going to use the Indian chief Sokotoa. So sine is going to be the opposite over hypotenuse. Cosine is going to be the adjacent over hypotenuse, and tangent is going to be the opposite over the adjacent. Okay, sorry about that. Sorry if anybody ever walks in. Hopefully I'll be able to pause this and hop right back in where I left off. Okay, so next, number 2. The secant ratio is the reciprocal of the sine ratio. That is false. Okay, so how are we going to change that? What is the ratio of the reciprocal of the sine ratio is going to be not the secant, okay? It's going to be the cosine. So that we're going to change to cosine, okay? That's the reciprocal. Oh, sorry, not cosine, cosecant. There it is. So cosecant is the reciprocal of the sine ratio. Okay? Next, an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to the objective below. So let's think about this for a second. Angle of elevation formed, here's my nice person standing there, is formed by a horizontal line, okay, a horizontal line, and an observer's line of sight to an object below the line. There's my object, okay? If I'm looking down at an object, okay, that is not an angle of elevation. It would be an angle of depression, okay? So that's an angle of depression, not an angle of elevation. So this is also false. Okay? Number 4, radian measure of an angle is equal to the ratio of the length of its intercepted arc to the radius. This is true. That's the definition of a radian. That's how we figure out what a radian is, or how big a radian is, right? It's the measure of an angle. It's the ratio of an intercepted arc on a circle to the radius. Okay. Next, the rate at which an object moves along a circular path is called its linear speed. That is also true. Okay. 6, 0, pi, and negative 2 pi over 2 are examples of reference angles. Okay. These are false because of that one right there. Okay. All reference angles are always positive. This also, pi is also not a reference angle. Reference angles are positive, and they are in between 0 and pi over 2. Okay. These, however, are special angles. They are quadrantial angles, right? They are angles that end on a quadrant line. Okay. Number 7, the period of the graph of y equals 4 sine x sine 3x is 4. So is my period 4? Right in the front there. That is also false. That number in the front is the amplitude. Okay, the amplitude. Okay. Number 8, for f of x cosine bx, as b increases, the frequency decreases. Okay, so as b goes up, remember my formula for frequency is going to be frequency is the inverse of period. So the formula for frequency is going to be b over 2 pi. So if b goes up, the frequency is going to go up. So this is not going to be true. This is going to be false. But what can we replace frequency with? Okay. If I think about it, if I replace frequency with this inverse, with the period, which is equal to 2 pi over b, okay, if I make b go up now, as the denominator goes up, the fraction gets smaller and smaller, the frequency decreases. Okay, so in order to make, or sorry, the period decreases. In order to make the period decrease, we can increase the denominator there. Okay. Next, 9. The range of the arcsine function is 0 to pi. Okay. That is false also, okay, because the range of the arc cosine, okay, arc cosine is going to be 0 to pi. Okay. Arc sine is going to go from negative pi over 2 to pi over 2, just like arc tangent, from negative pi over 2 to pi over 2. And last, the law of sines can be used to determine unknown side lengths of measures of some triangles. That is true. Okay? So hopefully most of you followed along with this and were able to get the right answers. Okay? So now what I'm going to do is I'm going to go through each of the sections. Take a minute to pause or go back if you need to review the vocabulary or the true-false. Okay, so now we're going to go through all 7 sections on the review. All right? The first section is all about right-angle trigonometry. So what we're going to do here is we're going to make all these different ratios with a right triangle. My sine, opposite over hypotenuse, the cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Comes right from SOHCAHTOA. And then my cosecant, secant, and cotangent are the opposites. So basically you just flip over the fraction. Remember that if there's a radical in the denominator, you have to rationalize that fraction. Okay? So let's look at my first example. Okay? We're going to find the value of x here. So I know that my angle right there, 38, is giving me the opposite side. Okay? And x, I'm looking for the adjacent side, the angle right next to it. In this case, the hypotenuse, which is right here, I don't need to know. Okay, so I have to think about what ratio does opposite and adjacent, and the answer to that is tangent right here. Okay, so from there, I'm going to put tangent of 38 is equal to 10 over x, opposite over adjacent. Okay. As you can see from the directions right here, multiply each side by x, divide by the tangent, use your calculator to get your answer of 12. Then make sure your answer makes sense. Okay? It should be 38. 38 degrees is going to be the smallest angle in this triangle, so 10 should be the smallest side of this triangle, which means that my answer should be over 10, which it is. Okay? So let's take a look at a couple example problems. Right, so the first one say that find the exact values of the 6 trigonometric functions of theta. Okay, so I'm going to find the exact values of the 6 trig functions of theta. So it's going to be the sine of theta, cosine of theta, tangent theta, cosecant theta, secant theta, and cotangent. There we go, cotangent of theta. Okay, so basically, all I'm going to do for these six, okay, I'm going to do number 11 right now. Okay? All we have to do for these six is put the right ratios. So sine, okay, look at the angle that I'm starting with. I'm starting with theta, which is right there. Sine is opposite over adjacent. So that turns into, sine is opposite over hypotenuse. 36 over 39. Don't leave things that are not reduced, okay? So reduce this to 12 over 13 for sine, okay? Cosine, okay, is going to be adjacent over hypotenuse. So this is going to be 15 over 39. And in this case, we can reduce this to 15 over 39, yeah, to 5 over 13. Okay? Tangent reduces to now opposite over hypotenuse. Or sorry, opposite over adjacent. So this is going to reduce to 12 over 5. Okay? Cosecant. Cosecant is going to reduce to 13 over 12. Secant is going to reduce to 13 over 5. And obviously, if you look at these two, they're just going to be opposites of each other. Okay? And then finally, cotangent is going to be 5 over 12. Okay? 12, number 12, I'm not going to take a look at. It's pretty much the same thing as number 11. All right? Next, 13 and 14. Find the value of x, round to the nearest tenth. So basically, what you have to do here in these problems is realize that I know this angle right here. Okay? I want to find the side opposite of it. That's why there's an x over there. I know this side, which is the hypotenuse. So basically, I have to think to myself, what ratio does the opposite over hypotenuse? So opposite over hypotenuse would be the sine. So the sine of 27 is going to be equal to the opposite over the hypotenuse. Okay? Multiply both sides by 11. And so we have 11 sine 27 is equal to x, which is going to be equal to, work it out on your calculator, about 5.0. Okay? For number 9, or for number 14, we're dealing with a different angle. We're dealing with this angle right here, where we have different ratio of sides. This is the hypotenuse, and this side, number 9, would be the adjacent side. X is the hypotenuse because it is the side opposite of the right angle. Okay? So I just set up my ratio. I have to decide what ratio do I need. I'm going to use the cosine. The cosine of 42 is equal to adjacent over hypotenuse. Okay? In this case, multiply both sides by x. So we have x cosine 42 is equal to 9. Divide both sides by the cosine of 42. And so x is going to be equal to about 12.1. Okay? Next, for questions like this, okay, find the measure of the angle theta round to the degree. Okay, so now we are looking for an angle. Much different than these questions right here, where we have the angle and we're looking for the side. So in this case, we are going to use inverse ratios. So because I am looking for this theta, and I know the opposite side, I know the hypotenuse. Opposite and hypotenuse are sine. So the sine of theta is equal to the opposite over the hypotenuse. So that means theta is equal to the inverse sine of 6 over 18. Be sure, if you want your answer in degrees, your calculator is in degrees. So theta in this case is going to be equal to 19 degrees. For this second problem, number 16, we have theta right there. Okay? In this case, we know the opposite side and we know the adjacent side. We don't know the hypotenuse, which is this side across from the right angle. Okay, so I need a ratio that is going to do the opposite and the adjacent. So that is going to be my tangent. So the tangent of theta is equal to opposite over adjacent. So that means theta is equal to the inverse tangent of 11 over 5, which gives me an answer of 66 degrees. And that's pretty much everything you're going to need from 4-1. To review real quick, we have making ratios, finding a side, finding an angle, all in right triangles. Very important, all in right triangles. Okay? Section 2. Section 2 is where we converted degrees to radians, radians back to degrees. We talked about linear speed and angular speed. So my example problem right here was to identify all the coterminal angles with 5 pi over 12, find one and draw a positive and one negative coterminal angle. So because it's in radians, we're going to add radians, which is once around the circle, it's going to be 2 pi. So we have to figure out all the angles that are going to end in the same place as 5 pi over 12. Okay? If we look at this example right here, we see that we go around the circle. Okay? We go around the circle once, and then we keep going. Okay? So my original angle, 5 pi over 6, is that far. My next angle, my coterminal angle, as I spin around the circle one whole time, 2 pi plus 5 pi over 6, we get 17 pi over 6. If we think about this then in a negative coterminal angle, we have my 5 pi over 6 going that way. Now we're going to go back the opposite way, and we're going to spin around the circle this way. So we take 2 pi and subtract it. Okay, and we get 7 pi over 6. The types of questions you will have in this section mostly focus on, at first, changing degrees to radians. So my first question right here, to change degrees to radians, we multiply by pi over 180. Okay? Doing this and simplifying the fraction gives me 3 pi over 4. Okay? For 450, I realized that that angle is going to be greater than 2 because it's bigger than 360. But we do it the same way. We multiply by pi over 180. Doing this gives me 5 pi over 2. For the next one, 7 pi over 4, we're going to do the opposite. We're going to multiply by 180 over pi. Okay, that's going to cancel out the pi's and leave me with my degrees, which is going to be 315 degrees. Number 20, same thing. Multiply by 180 over pi, and we're going to be left with 234. Okay. Next type of question. Identify all angles and coterminal angles with a given angle, then find and draw one positive, one negative. We're not going to worry about drawing. Let's just find a nice coterminal angle. So for 21, okay, because it's in degrees, we're going to stick with degrees. So we're going to have 342. All we have to do to that is going to add 360. Whoops. We're going to add 360. Doing that gives me 702. Okay? That is a positive coterminal angle. Okay? Next, to find a negative coterminal angle, we have to subtract 360. Doing that is going to give me a negative 18. That's one positive, one negative coterminal angle, all just by adding or subtracting 360. For the second problem, for number 22, we're going to do the same thing, only we're going to add or subtract 2 pi because this is in radians. When I do that, I can get, if I add 2 pi, I get 11 pi over 6. If I subtract 2 pi, I can get negative 13 pi over 6, both of which are my positive and negative coterminal angle. Next, area. To find the area, you're going to need the formula for area of a sector. The formula for area of a sector is 1/2 r squared theta, where theta must be in radians. Okay? Formula for arc length is just arc times theta, which again, theta must be in the radians. So to do the first one, we have to change 31 to radians. So let's do that. So we have 31, 180. So we are going to get, okay, so 31 in radians is 31 pi over 180. Doesn't really simplify any better than that. So my area here is going to be 1/2 r squared, 14 squared, times theta, which is right there. Okay. Working all this out, plugging this into a calculator, gives me about 53. Whoops, not degrees. 53 inches squared, since we're dealing with area. Over here in 24, the answer, the angle is already in radians. So all I have to do here, I don't have to convert anything. We have 1/2 10 squared times 47 pi over 30, which gives me an answer of about 246 meters squared. Okay? And that's basically the information that you need for 4-2. 4-3, we start dealing with functions on the unit circle. Remember that angle in radians contains x and y. Cosine is equal to x over the radius. Sine is equal to y over the radius. Tangent equals y over x. And the radius, of course, we can find by using the Pythagorean theorem. The next point here, angle containing x, y in the unit circle. Okay, if we're dealing with the unit circle, okay, the cosine is equal to x, sine is equal to y, and tangent is y over x. If we're dealing with something that's not a unit circle, okay, you have to factor in the radius up here. The unit, okay, so here's a quick example. Let cosine of theta equal 5 over 13. Find the exact values of the 5 remaining trig functions. Right? Because we know that cosine is going to be x over r, we can use x over r to find y using the Pythagorean theorem. Okay? So we can figure out, once we figure out y, now we just plug in our ratios like we did in 4-1. The sine is y over r, the cosine is, the cosine we already have, tangent is y over x, secant is the inverse of cosine, cosecant is the inverse of sine, and then cotangent is the inverse of tangent. Okay? Once you have one, you can easily get all 5. Here's a quick picture of the unit circle, which you guys all know how to do because you all pretty much did very well on the unit circle quiz. Make sure if you have trouble with this or if you don't know something, make sure you review the unit circle. Okay? Most of the stuff that we're going to do is made much, much easier by remembering the unit circle. If you have trouble with this, make yourself a quick little, at least this section, make yourself a quick little note at the beginning of the test of maybe the first quadrant. That'll help you out. Okay? So, first, find reference angles. Okay, so we're not going to deal too much with sketching, but definitely we are going to find the reference angles. So 240, think about, well, let's sketch this to be easier. Okay, think about where 240 is. That's 180. We go a little bit more, we get to 240. Okay, so what's the reference angle going to be there? It's going to be 60, because that's 180 plus 60 gives me my 240. For 26, for 75, the reference angle is just 75, right? It's not bigger than 90. We're looking for angles that are in between 0 and 90 degrees. Or in terms of radians, like number 27, 0 and pi over 2. So 3 pi over 4, if I was going to draw this, that's negative pi over 2. This would be negative 3 pi over 4. So my reference angle would be from here to here, okay, from negative 3 pi over 4 to negative pi, okay, it's going to be a positive pi over 4. And then for 28, right, we just figure out where this angle is, okay? Well, I know that's pi over 2, which is 9 pi over 18. So 11 pi over 18 is going to be a little bit bigger. It's going to be there, which means that from my reference angle is how far away from the x-axis it is, how far away from pi. So my answer is going to be 7 pi over 18. Okay. And then the next type of question is find the exact values where the cosine is 2 over 5. Okay, so for this, we're going to have to figure out the other side. So the other side of this one is going to be, well, cosine is going to be, cosine of theta is going to be x over r, which is going to be 2 over 5. So that means that I need y. So I know that 5 squared is going to be equal to 2 squared plus y squared. So that's going to be 25 minus, right, 4 is going to be equal to y squared. So that's going to be 21 is going to be equal to y squared. Take the square root of both sides, and we have that y is the square root of 21. So now we have all our values. We have x is 2, y is the square root of 21, and r is going to be 5. So based on this, we can now figure out the rest of the ratios. Okay, I don't want to write them all, but just realize that, for example, when we do something like, when we do anything with y in the denominator, you're going to have to rationalize the denominator. So sine would be y over r, which is going to be radical 21 over 5. Okay? But something like cosecant, which is the opposite of sine. So if sine theta is going to be radical 21 over 5. Okay? But cosecant is going to be 5 over radical 21, which we can't leave like that, so we have to rationalize the denominator, so it turns into 5 radical 21 over 21. Pretty much nobody should have a problem with that. Okay. 30, I'm going to skip. It's the same as 29. Okay. Find the exact value of each expression. If undefined, write undefined. So for these, we basically just have to figure out, using the unit circle, what is the sine of 180? Well, realizing that sine is going to be your y coordinate, the sine of 180 is going to be 0. Now, tangents become a little bit difficult, more difficult, right? We want the cotangent of 11 pi over 6. So basically, we just have to remember the unit circle and figure out what the sine and cosine of 11 pi over 6 is, and then divide the two. If you can't remember, okay? So thinking to 11 pi over 6, which is going to be right there, right, with a reference angle of 30, okay? my points on the unit circle there are going to be radical 3 over 2 and negative 1/2. So cotangent is going to be x over y, right? Cosine over sine. All right, it's the opposite of tangent, which is sine over cosine. So this turns into, and it's going to be a negative, it's going to be radical 3 over 2 over 1/2, which is just going to reduce to a negative radical 3. Okay? Next, 4-4. So 4-4 is all about graphing sine and cosine. So basically in this section, you kind of just have to remember a few of the formulas because we're not going to have enough time to graph the whole function. So just remember what the standard form is here. Y equals a sine bx plus c plus d, or cosine. Okay? Amplitude is the absolute value of a, right? Negatives there do reflections. Period is 2 pi over absolute value of b. Frequency is b over 2 pi. Phase shift is negative c over b, and vertical shift is d. If you can remember what those four things stand, or what those four formulas are, and what the different letters mean, that's what most of the questions on this section are going to be about, since we're limited for time. Okay? So something like this might give you a question that says state the amplitude, period, frequency, phase shift, and vertical shift of this function. We probably have to leave out graphs unless there is a multiple choice question, which is possible. Okay? Anyway, so here we have a is equal to 4. That comes right from there. B is equal to 1, which comes right from the number in front of x. C is there, and D is there. So my amplitude, right? My amplitude in red right here gives me the absolute value of 4, or just 4. My period turns into 2 pi over b, or just 2 pi, because b is 1. My phase shift becomes pi over 2, because c is negative pi over 2, so it's negative pi over 2 over 1. And then finally, my vertical shift is negative 4. Okay, so when I plug all these things into an equation, you can see the blue sine function. Okay, and now I'm going to graph my new function, which is going to be down because of the vertical shift. It's also going to be this going to have the same period, okay, same frequency. It's also going to be taller because of the amplitude shift. Okay? So basically, the big ones here are phase shift and amplitude shift. So, questions that you're going to have to deal with in this section, like I said, all right? Describe how the graphs are related. So this 5 right there, because it's in the front, right, that's an amplitude change. So the way these two are related is we start with the sine x, and this function has been stretched. It's been stretched vertically, okay? The amplitude is greater. The amplitude is now 5, okay? And don't forget that the distance between the top and the bottom is 2 times the amplitude. So it's 10 between the top sine wave and the bottom sine wave. Now for 38, right here, for this cosine, right, now the 2 inside changes the period. So the period is going to equal 2 pi over the absolute value of b. So this is going to be 2 pi over 2. So my period is going to be pi. That means that the cosine will finish one complete graph every pi. Okay. So for instance, this question is a good question as long as we don't have to graph it. Okay, so we're going to take out this, and this is the type of question you might have. Amplitude, period, frequency, phase shift, vertical shift. So let's start with the amplitude. Okay? A is going to be equal to 2. Okay? Next, period. Period is going to equal to, okay, 2 pi over b, which is 1, so it's just 2 pi. Okay? Frequency. Frequency is also going to be right here. Frequency is going to be equal to 1 over 2 pi, right? The inverse of 2 pi. And then there is no vertical shift. We'll get to, phase shift. So phase shift, okay? Phase shift is equal to negative c over b, which is going to be equal to negative pi over 1. The negatives cancel each other out. So my phase shift is pi. So now if I were to graph this, I realize that it would be, the wave crest will be higher, the period is not changed, and everything is shifted pi to the right. Okay? All right, from 4-5, 4-5 was all about graphing our other trig functions. So instead of sine and cosine, we're now going to be graphing tangent, cotangent, secant, cosecant, and that's pretty much it. Also, we talked about this thing right here, which is multiplying a sine or a cosine function by another function, which is called a dampening function. And f of x is my dampening factor, where, if you remember, we had the question about plucking a guitar, how far away how like the string vibrating. So that's going to be something like that. We might not get to that, but let's take a look at a secant function. Okay, so remember how secant functions work is they are the inverse of the sine and cosine functions. So from here, you can see that where the sine function crosses the 0, okay, the secant function has an asymptote. Where the sine function reaches a maximum or a minimum, the secant function touches the same point and goes in the opposite direction. Most of the other properties behave the same. 2 is going to be my or it's not my amplitude. 2 is a horizontal stretch or compression, vertical stretch or compression. Okay, we don't call it an amplitude because these functions go up forever. B is still in here, and that would be my period change. This is still C, my phase shift, and then this function had no D, nothing on the back of it. Okay, so it is shifted left pi over 4 units, and the period is still going to be 2 pi. So basically, all the important stuff about these functions are going to stay the same. An important thing to remember, however, is that the period for tangent and cotangent are going to be pi instead of 2 pi. Okay. So, again, sketching the graphs might be a little bit much in our time constraints. So basically what we're going to do is we're going to just find the asymptotes. So for this one, the asymptote right here is not going to change. So it still remains, the asymptotes remain at negative pi over 2 and pi over 2. Right? Tangent has an asymptote anywhere, since it is sine over cosine, anywhere that cosine is equal to 0. All the places where cosine is equal to 0, tangent is going to have an asymptote. And that's the same thing for 46, right? Tangent still, the 1/2 doesn't change my asymptotes. Okay, so tangent is still going to have an asymptote every pi over 2. Okay, but this right here would affect it. It's a phase shift. But since my b is 1, my phase shift of pi over 2 to the right just moves the asymptotes on top of each other. So my asymptotes are now negative pi over 2, pi over 2, 3 pi over 2, every pi over 2 still, right? They just took one asymptote, right? They took my 2 asymptotes, and they just shifted them over on top of other asymptotes. Okay? Not going to go too crazy, again, like I said, with graphing the different functions. Inverse trig functions. Here's where we are going to have a few problems. Okay? Remember our constraints, that the inverse sign only exists when x is between -1 and 1 and y is between -2 pi and pi, or sorry, negative pi over 2 and pi over 2. The inverse cosine only exists if x is between -1 and 1 and y is in between 0 and pi. The inverse tangent exists for any x, but only in between negative pi over 2 and pi over 2, not including pi over 2 and pi over 2, because those are asymptotes of my cosine, of my tangent function. Okay. So the question you're going to kind of get like this is find the exact value of an arctan. Okay. So remember that find a point on the unit circle with pi over 2 as a tangent and figure out which one of those is within the interval. Okay. The questions that you're going to get are going to look something like this. Okay. The way we read this is, where is sine equal to -1, right? When we look for inverse sines, cosines, or arc sines, cosines mean the same thing. We are trying to figure out an angle, just like we did in the very beginning, okay, when we were solving for the angle of a right triangle and using the inverse sine or inverse tangent or cosine to do so. So, where is sine equal to -1? Remember, it's equal to -1 two different, or sorry, it's equal to -1 only one spot, okay? And when we think about it, right, if we think about our unit circle, it's equal to -1 right there. But remember what my constraints are, is that I want my inverse sine to be between negative pi over 2 and pi over 2. So which means the angle is going to be negative pi over 2. For 54, where is cosine equal to positive 3 radical 3 over 2? Well, remembering back from the unit circle, that should be easy. It's pi over 6. For this one, the tangent of -1, sorry, the inverse tangent of negative radical 3 over 3. Think back to the unit circle. Think about which one would be right. And for here, we have a negative pi over 6. Now, where's the arc sine equal to, where's the sine equal to 0? Well, that's at 0. Okay? It's also at pi, but remember that's outside of our interval. Okay? So where's the tangent equal to -1? Well, that's going to be negative pi over 4. The arc cosine is equal to radical 2 over 2 at a positive pi over 4. Okay? And then finally, okay, we have nested cosine and sine functions. Now, these two just happen to be the same. When these are the same, okay, we are talking about the same angle. We're going from one angle back to the other one. So this says, what's the sine of radical of pi over 3, and at what angle is that answer the sine of? So in this case, they can just both cancel each other out, and my answer to this is negative pi over 3, because we're going right back to where we started. However, for this one, because this is outside of the interval, -3 pi is outside of the interval of where the inverse cosine is defined, I have to find a coterminal angle with -3 pi. Okay, so if I think about it, if I think about -3 pi, right, I go around once, that's 2 pi. Once more, I'm going to be right here. Okay, that angle can be defined as pi. Okay, sorry about that. So we spin around the circle once and then stop here again, okay? And we define that point as pi, because our interval for inverse cosine is in between 0 and pi. Okay? Now, some types of questions that you might see are going to have mixed sines and cosines. For instance, you could get a problem that looks like this. What is the sine of the inverse tangent of 1 minus the inverse sine of 1. Okay? So to do this, you have to figure out, okay, first, let's take this parentheses first. Where is the tangent equal to 1? Well, that's going to be at pi over 4. Minus, where is the sine equal to 1? So I know that my sine is going to be pi over 2. Pi over 2, so if we subtract this, if we subtract pi over 4 minus pi over 2, I'm going to get a negative pi over 4. Okay? So now, this whole part inside of the parentheses is going to equal negative pi over 4. So my question now becomes, where is the sine, or sorry, what is the sine of negative pi over 4? Okay, so you do everything inside the parentheses first, and then do what's on outside the parentheses. So the answer to this then becomes, what's the sine of negative pi over 4? Right? We think about going down here, right there. It's going to be radical 2 over 2. Good. Next, the last section, what we did Friday and today, it is the law of sines and law of cosines. The law of sines sets up 3 ratios using sine. Sine A over A equals sine B over B, sine C over C. Whereas the law of cosines sets up 3 things that look kind of like the Pythagorean theorem to figure out all the different sides or all the different angles of a triangle. Remember that some triangles will not be possible. So in this case, because A is less than H, there's no triangle that can be formed, right? A is less than B and A is less than H. Therefore, this triangle is not possible because A is an acute angle. Right? So you need to remember all those different possibilities for how triangles work. So let's look at these couple problems. Okay? So A is 11, B is 6, and A is 22. So first, we have to decide how many solutions there are. So for 61, there's only going to be one solution because A is greater than B. Okay? So that's easy for us. So that means that we have the sine of 22 over 11 is equal to the sine of B over 6. That is my first ratio. So I can solve that for B. Once I have the angle B, I then can get angle C because we know that all angles in a triangle add up to 360. And once I get the other angle, I can solve again for the other side. So let's do this real quick. 6 sine 22 is going to be equal to 11 sine B. I divide both sides by 11. Okay. This left side over here is just going to be a decimal. Okay. Plug it into your calculator. So we have 6 sine 22 divided by 11 is going to be equal to 0.204. Okay. To solve for B now, we take the inverse. So because 0.204 is equal to sine B, that means B is equal to the inverse sine of 0.204. Okay. So plugging that into your calculator gives you 11.7. Okay. Or we'll nice round up nearest degree, so we'll round up to 12. Okay? Which means that because A is 22 and B is 12, C must be 146. Okay? Now that we have C, I can set up another ratio. Sine 22 over 11 is equal to the sine of 146 over C. Solve for C. Let's try number 46, which is slightly more difficult. Okay? Because we have to figure out, because A is acute, and because A is acute, A is less than B, we have to find H. So H is going to be equal to okay, so first step here is to find H and to figure out if this triangle has no solutions or two solutions. So we know that H is going to be equal to B sine of A, which is going to be 10 sine 42, and that's going to equal 6.7. Okay, so that means A is bigger than H, which means we are going to have two solutions. So my first solution is going to look like this. Okay, first solution in red. We're going to have sine of 42 over 9 is going to be equal to the sine of B over 10. Okay. Working that out, we get my angle B is going to equal 48, which means that C has to be equal to 42 and 48 minus 180, which C is going to be equal to 90. Okay? It's okay that that turns into a right angle, a little bit weird. Okay? Setting up another ratio, that sine of 42 over 9 is equal to the sine of 90 over C, gives me that C, little c, the side is going to equal 13.5. Now, we have to do this over again because, like I said, there are two solutions. Okay, so in blue over here is my second solution. Okay, sine of 42 over 9 is still our ratio. Okay, but now we have to figure out how big my second angle is going to be. If my first angle is going to be 48, my second angle has to be 180 minus 48. Because think about this. If I have my triangle right here, okay, here was my height. Here was my second possibility of a triangle. My first triangle in red is right there. My next triangle that I'm doing right now is this one in blue. So we see that my red angle right here has to be the same as this one by the rules of an isosceles triangle, which makes my blue angle right there add up to 80 degrees with it. Okay? So that means that my first ratio is the sine of 42 over 9 is equal to the sine of 132 over B. Okay? And that will give me, sine of 132 over 10. And we can check that if you want. Okay? But that will give me my second angle and my C. So B, in this case, is going to be 132. C, my next angle is going to have to be 9 because I have to add up to 180, which makes little c equal to 1, sorry, not 9, 6, 1.4. Okay? And that makes sense because this part in the blue is going to be much shorter than this leg down here in red. And of course, the shorter side must be across from the shortest angle. Other problems that might happen is when we have when we have that A is going to be less than the H. If A is less than H, then this triangle is not possible. There is no solution. Okay? So next, solving each triangle. Okay. Solving each triangle, we have to decide what we know. In this case, we have A, B, and C. In order to figure out our angles, if we have three sides, we are going to use the law of cosines. It doesn't matter which angle we solve for first. Okay? My two law of cosines would then be, if I want to start with a, right, a squared is going to equal to b squared plus c squared minus 2bc cosine of a. That will solve me angle A, which gives me 13 squared is equal to 12 squared plus 8 squared minus 2 times 12 times 8 cosine of A. Solving all that for A gives me an answer of 78 degrees. Okay. To find B, I do the same thing, only I put the numbers in a different spot. So if I'm going to get b squared on this side, right, this turns into a squared plus c squared minus 2ac cosine of b. This will now solve the exact same thing. Now that I have an angle, however, if I wanted to, I could also use the law of sines. So because I know that angle A is going to be equal to 78, I could also do the sine of 78 over 13 is equal to the sine of B over 12. Either one of those will get me to the right answer. Okay? And then 66, to solve 66, I'm going to use the law of cosines. In fact, now I'm going to solve for C first because that's the only side I don't know. And I'm going to use C squared, right? C squared is equal to A squared plus B squared minus 2AC cosine of C. And I have all those pieces except for C squared. So just plug them in and solve. Okay. As far as the word problems and the practice test, I will include a video to the rest of those tomorrow since this one is getting a little bit long. Okay? So hopefully you have time tonight to take a look at all this stuff, and I will finish this up with a part 2 tomorrow because I'm getting tired of talking to myself in an empty room. I will see you guys all tomorrow.